This video will show you how to create an inverse kinematic simulation. We will get into two parts. First, we will set the inverse kinematics class. Then, we will set and run an inverse kinematic simulation. Create a new class called pos_to_real. Class type is model. Insert it in Tuto Kinematics. Drag and drop a flange B. An angle sensor. A gain. A real output. Set the 4 blocks as vectors of size 6. Connect the blocks as shown. For the value of the gain, search in Modelica, constants. Copy R2D. Paste it in the gain's value with Ctrl+V. Class can be pimped. Now, create a new class called KUKA Inverse Kinematics. Class type is model. Insert it in Tuto Kinematics. Drag and drop the KUKA Kinematics imported class created in the first part. The pos_to_real class. KUKA set pos0 also created in the first part. Connect the blocks as shown. Drag and drop 6 real outputs. Name them A1 to A6. Connect them as shown. The outputs will be the result of the inverse kinematic simulation. Now, we are going to create a new class that will be processing the inverse kinematics. Create a new class called XYZ_to_inverse. Class type is model. Insert it in Tuto Kinematics. Drag and drop in this new class 3 real inputs.
You can name them X, Y and Z.
A gain. A position from mechanics, translational, sources. 3 prismatics. A frame A and a frame B. Set the gain to 1/1000th. Set the gain and the position as vectors of size 3. Set exact to false for the position. Enable use axis flange for all prismatic and set 1 for X translation, another 1 for Y translation and the last 1 for Z translation. Connect the blocks as shown. Class can be pimped. Go back to KUKA Inverse Kinematics. Drag and drop XYZ_to_inverse. A fixed rotation. A fixed translation. Connect the blocks as shown. The rotation and the translation will set a local frame for the input coordinates. Now, let's create a simulation. Drag and drop 3 double ramps. Connect them to the XYZ connectors of the XYZ_to_inverse class. Set some values in the ramps to have our movement. The XYZ values will control the position of the tool. Start the simulation. Here are the output values, which are the angular values of each axis. You can apply a modulo for a better readability. Here are the inputs. As you can see, the tool's XYZ coordinates are controlled and the angles of the actual axis of the robot are processed during the simulation. That kind of simulation will be helpful for machining purpose as the tool displacement will drive the axis position of the robot. Let's summarize what we have learnt during this video. First, we saw how to create a class that processes inverse kinematics simulation. Then, we saw how to set the inverse kinematics simulation and how to show the results.